antagonists in the opioid category. But as you can see, it took about 100 years from the ether dome activity to the recognition that nalorphine, which you don't hear much about anymore, but there's I think another final exam question that you can get right. Now, nalorphine is it's an opioid antagonist, but it's not a 100% antagonist. A few small fractional percentage points of agonistic activity are left there in terms of the message that nalorphine delivers to a receptor. But despite that fact that it's not a 100% antagonist like naloxone is, nalorphine nevertheless plays a huge role in the history of opioid pharmacology because of its premier entry as the first almost complete antagonist about midway through the 20th century. Took a few more decades, but Pert and Snyder's magnificent work at Johns Hopkins identified a new class of receptors at that time. Now, the opioid receptors are just sort of, common sense to us, I suppose, but that was a huge event back in the early 1970s, and coupled with the almost simultaneous discovery of endogenous opioids by a number of different groups that were pursuing that research in the mid to late 1970s. That was a really exciting time in pharmacology, and the fact that there were co-discoverers of the endogenous opioids, as well as the receptors too. Avram Goldstein at Stanford was also a big early player in the realm of the receptors, as well as the endogenous opioids. Many groups throughout the world, including Dr. Wei's group at UCSF, were pursuing, these holy grail aspects of opioid pharmacology, the receptors and the endogenous substances. Scientific meetings at the time were really exciting because people would be coming to the meeting with an abstract saying something like, "Well, we've got some really neat new stuff to report on the opioids," and people in the field knew that there were going to be some really big changes to be announced. So it was really exciting stuff, and it was a race. You hear about these sort of races of discovery in scientific investigation, and the opioid receptor endogenous opioid realm was certainly a fantastic scientific race that was going on just a few decades ago. And then all sorts of new developments since then that have been quite important to the field. So we talked about a little bit about regulation, and I won't do much with that. Again, the fulcrum regulation in the U.S. is the Harrison Act, although for all drug categories, nothing's more important than the Pure Food and Drugs Act. So we traced a little bit of sort of the frustrations that existed for many decades as people were trying to basically understand, what is the nature of tolerance and dependence with respect to the opioids, as well as in a more general sense in pharmacology, the whole realm of substances which are tolerance producing and dependency producing, and in the little bit more complicated aspects of addiction that Katie was talking about on Tuesday, led to tremendous analysis of evidence to try to figure out what is the nature of these things that we call tolerance and dependence. And as you can see, for a long time, uh, there wasn't a lot of progress made. So before I sort of have these dabs of history in there, and we go back and forth between the history and the more straightforward scientific stuff. But anyway, we reminded ourselves about the nature, as we understand it now, of painful processing in a living system, and recognize that current theory pretty much suggests about a triple header there, in the sense of sensation, perception, and emotion being the key players in in our grasp on painful processes. And a little graphic of what was just talked about in words in the previous slide, and more history. Still struggling to find out what's going on. But I will reemphasize Dr. Meyer's point: to understand the epidemiology of opioid use, factors other than unchanging pharmacological effects of drugs must be considered. Bingo for what's going on in terms of the huge opioid epidemic. And we'll undoubtedly talk more about this here in the next few minutes. Here was an exciting conference, but not really in the context of tolerance and dependence. Still a big mystery by the 1980s. But as we moved past the 80s, and not only were developments occurring in the opioid field, but tremendous developments overall in terms of neuroscience and related areas, all of which contribute to our understanding of what's going on, began to focus us on the whole realm of reinforcement reward in the brain, and any drug substance, as far as we know now, that is highly rewarding, opioid or otherwise, is likely to be a major candidate for dependency and addiction phenomena, if we want to use that terminology. So as we catch up with the current time frame, this whole idea of psychological reinforcement and affective reward appears to be at the very heart of dependency phenomena. Now, the specific aspects of that in terms of, on a molecular basis, how you actually produce those rewarding signals is still an active area of investigation. So, it's not like by understanding this generality of reinforcement and reward that we understand every bit of the underlying mechanisms. We don't. But with our tremendous ability to sort of interrogate receptors anymore, the answers, the specific mechanical answers to these questions are becoming better and better known each year. Well, there's a nice pair. Be interesting to know how they're. I don't know how old the cat Bob is by now. Hopefully he's still alive. Beautiful cat. Being playful there. Busking, which was a word I didn't know. I had to look it up. And you folks probably have been more familiar with it than I am, but it's street Street performance. Well, categorization and classification of these phenomena, as well as a variety of other things of importance to us, um, resides with the DSM, or at least it does to a very large extent, especially in the United States. Although I think it's pretty much a worldwide resource. American Psychiatric Association has been publishing the DSM for some years and guiding our thought processes uh, about mental disorders and drug use for a very long time. If you've never had a chance to actually look at the DSM itself, you've heard about it, but you may or may not have actually had a chance to take a look at it. It's worth a few minutes of your time to sort of see the framework which is being utilized to diagnose problems with respect to the nervous system, uh, mental processes, and of course, the involvement of drugs for better or for worse in all those things. Um, I think our little library on second floor of the Skaggs has a copy of the current DSM, which is 5, and previous editions of the DSM. So I think if you wanted to stop by there sometime and take a look at that, that you could find it on the shelves there. If not, or if there's greater interest than just one copy would do, let me know, and I'll share my own copy of the current DSM, as well as I think I've got it back a time or two in terms of earlier editions, which are quite a bit different. The field has been evolving fairly substantially, and you can sort of tell that from how long it took to get from DSM 4 to 5. It was a very long time, and each year they'd be saying, "Well, we're just about ready to publish it," and then the year would go by and it wasn't out. It's just such a complex matter to put something like this together that it takes forever to do it. And so, just a few tidbits about the DSM, particularly aspects of the DSM which changed between DSM 4 and DSM 5. And I was thinking that I had a slide in there showing a little bit more than that, but I've got multiple versions of this presentation, and it's probably on another one. So moving back into the mechanistic realm of receptors and drugs, I put a summary slide together about the G protein coupled receptors, which is something that you folks are already experts in. So I'll just move on. Like many G protein coupled receptor areas, the opioid receptors are represented in multiple subtypes, and further by subtypes within those categories, which from an educational standpoint, of course, leads to complexity and trying to understand all that. But for our current applications, particularly with reference to our upcoming fourth exam, rest assured that the questions that will come forward with respect to opioids and receptors will be of the very most general categories, and we won't go into a lot of underlying detail in that practical sense. But in terms of understanding the research basis of opioid pharmacology and applications of the research basis to the clinic, of course, requires a greater attention to detail. Well, there's differential distribution of opioid receptors throughout our bodies, which, it's not too surprising, I suppose, because I think you could make a pretty much a statement like that with respect to a wide variety of receptor classifications in drugs which are matched up with those. So it's not exactly a surprising conclusion to understand that there are multiple subtypes. But here are a few particularly important aspects of this representation. The fact that opioid receptors are represented in both spinal cord and various brain regions, as well as at multiple non-nervous system sites throughout the body, suggests a wide variety of actions for opioid substances. Some of which we talk about all the time, and some of which we don't. But in some ways, from a pharmacological standpoint, it might be better if there wasn't such widespread representation of these receptors. It might cut back on some of the adversities of these substances a little bit, but that's nothing that as scientists and humans that we can control. We're just going along with nature in this particular regard. So the mu or MOR opioid receptor is an extraordinarily prominent one in terms of the ultimate analgesic or pain relieving properties of the opioids. So no wonder tremendous amount of attention has been paid to this particular subtype. The kappas and deltas have been studied also very, very extensively, but not as extensively as mu. And then I think we were perhaps getting close to the end of the lecture the other day to note that substances that we don't typically classify as opioids, like PCP and ketamine, show activity at a lot of different places in the system, but one of them is in the so-called sigma receptor, which is previously classified as an opioid receptor, but now sort of moved to its own address as opposed to being a part of the opioid receptors. Still a very important receptor, nevertheless. So I think you probably recall from physiology that prominent endogenous opioid subcategories are the endorphins, enkephalins, and dynorphins. And these are, of course, peptidal neurotransmitter substances. And they all sort of utilize that protective aspect of being present as pro, or sometimes even pro peptides prior to their cleavage to the active substances themselves. So the fact that the endogenous substances are peptides, of course, complicates the pharmacology in a sense, because peptides are so subject to proteolytic cleavage that in many cases the half-lives of the endogenous substances are quite short. But the non-peptidal exogenous opioids that you find in opium, as well as the ones which are synthetic, tend to have much longer half-lives than the peptidal endogenously occurring substances. The endorphin subclass itself is derived from POMC, pro-opiomelanocortin, and that's of not only great mechanistic and scientific importance, but also in a historical sense, in that um, ACTH, which you're all familiar with from the hormonal realm, as well as some other hormones, lipotropins and the melanocyte stimulating hormones, are all derived from POMC and therefore have some relationships with each other. And in a research sense, that was significant back in the 60s and 70s because um, groups that were working on ACTH uh, pharmacology and physiology, as well as POMC itself, were often at the leading edge of understanding um, the the opioids because of these relationships. So even though the opioids are not typically GABA targeted substances, they nevertheless are depressants and very substantial depressants at that. And so our activity scale of concentration and time that we talked about back with respect to the sedative hypnotics and related substances that Katie was talking about earlier, share the depressant spectrum of activity from disinhibition all the way, of course, to lethality and all points in between, including, as we've talked about a few times already, anesthesia. Um, so, the additive nature of depressant activity of the opioids themselves, as well as other depressant substances like the sedative hypnotics, is of utmost importance, and perhaps one of the most substantial generalities um, in our entire study of pharmacology is the way depressant substances work together, which is, of course, not always a good thing, and in some cases, it's actually an extraordinarily bad thing. So, being real minimalist about it, um, here's some things to definitely take home as far as opioid pharmacology is concerned. And if that's a take home in terms of practice, it's a take home in terms of the exam too. And so, there's a lot of different effects, but I've really tried to distill it down to, what is really most critical in terms of our understanding of opioid pharmacology. And of course, the fact that just right off the top, when you identify an opioid, you got to think, boom, analgesia, pain relief. Um, that's the top of the line right there. Um, all three modalities, what I mean by that is sensation, perception, and affect are involved in the pain relief that's associated with the opioids. And that's probably what makes them so substantial. I'm not sure I can give you an example of other types of pain relievers that cross all three of those categories. Um, and particularly the huge impact that the opioids have on the emotional side of pain, the affect side of it, is an absolute hallmark of their unique analgesia. Um, the opioids are tremendously effective as cough suppressants. And we especially think about codeine, I think, in that particular regard, where one, from a therapeutic aspect, might want to be targeting cough, but trying to minimize some of the other impact of the opioids leads to a pretty substantial use of codeine and some codeine analogs in that particular regard. Um, boy, is there representation of opioid receptors in the gut, and boy, are the opioids active in that regard. And although that can be used to advantage, for example, in severe diarrhea, um, uh, probably the more important aspect of this inhibition of gut motility is an adverse effect in individuals who are particularly sensitive to that particular aspect of opioid action really suffer a great deal in terms of uh, the, the, the opioids bringing GI motility to a virtual standstill, just literally stops it in the most severe cases. And that starts out being uncomfortable and can go clear to being quite dangerous in the extremes. Um, Although maybe not, a big deal in terms of um, effectiveness, nevertheless, a key characteristic of almost all opioid opioids that are agonists is pupillary constriction or meiosis. And in the last exam, we had um, questions on meiosis and mydriasis, which is the opposite of meiosis or pupillary dilation. But pinpoint pupils or pinpoint meiotic pupils that can be produced by the opioids is a hallmark effect. And we already know that the cholinergic substances um, can produce meiosis. So just because somebody has very small pupils does not necessarily mean that they're taking an opioid. But when you see a pinpoint pupil, it's certainly an indication that that individual may be taking an opioid. Well, there's Franny showing mydriasis or pupillary uh, dilation. And I thought it might be interesting to address the issue of, what's the relationship between, physiological pinpoint pupils and pharmacological pinpoint pupils. And that's addressed in this particular slide. So we kind of get GABA into the action here a little bit, and I'll just have you read over this. And if you have questions about it, you can let me know about that next time. But anyway, there is a relationship between the meiotic effects of the cholinergics and the opioids. So that was kind of a little bit of an unusual thing here. And you don't often hear about this side of it too much, what the relationship is. And pharmacology textbooks that don't cover it in this context could probably do a little bit better job if they included this little bit of detail. Well, we've been talking about adverse effects of these agents all along, so no need for me to languish here in this particular area. They're frank depressants. They're tremendously inhibitory in the gut, and on the agonist side, almost without exception, produce tolerance and dependence, although to varying degrees depending on the particular agent. So there's a whole bunch of different opioids out there, and we hear a lot about morphine as being the prototype. We hear a lot about heroin because of its role in mostly non-clinical pharmacology anymore. Although some parts of the world still utilize heroin as a therapeutic agent, but in the United States, heroin is a curse word almost, and many people don't recognize the fact that heroin was introduced as a clinical agent a little over 100 years ago. And again, it's about threefold greater efficacy compared to morphine, leads it to be used as a therapeutic agent elsewhere in the world. It is used in that sense in the United States too, but from a more black market perspective. Some other agents to bring to note here of the many that we could talk about include the synthetic methadone, which of course has a much longer time frame, um, both starting and stopping, and therefore um, uh, it has had significant utilization in treating opioid misuse disorders over the years. Although hopes to be able to withdraw in a complete manner from methadone are somewhat difficult to achieve, and so that often leads to maintenance use with methadone over long periods of time. Uh, Methadone can be used for its standard um, analgesic and other properties also. Um, Buprenorphine is has become a big agent in the last few years. It's a partial agonist and is found in combination with naloxone in the combination mixture, which we call Suboxone. And I think all of you have probably heard about Suboxone, excuse me, because it's become such an important factor in terms of treating opioid misuse disorders in recent years. So here's some other, again, by no means a complete list, but some other opioids of note. Um, Heroin is just the diacetyl uh, version of morphine, which enhances heroin's ability to cross the blood-brain barrier upon deacetylation in the brain. The heroin essentially operates as morphine at that level. Demerol is a synthetic, probably is just about as well known as methadone, and has had tremendous clinical application over the years, although perhaps we don't see as much clinical application of Demerol now as we did a few decades ago. Some other famous or infamous um, agonists include hydromorphone and oxycodone, and there are prominent partial agonists too, of which codeine is perhaps the best known, but pentazocine or Talwin is another partial agonist that you see quite a clinical play with. Um, so naloxone is, I think, the most famous of the 100% pure opioid antagonists. You hear tremendous about it, and we should, because it is a huge lifesaver. Um, and naltrexone is a very close relative of naloxone, with just a little bit of difference in pharmacokinetics, especially. So compared to nalorphine, naloxone and naltrexone have zero intrinsic activity, and that's why we talk about them as sort of quote unquote pure antagonists. Well, here's a really neat thing that need a couple more minutes to talk about, and I think we're out of time. So I'll stop and see if anybody has any questions. And next Tuesday, just a little bit of flair here in this final few aspects of the opioids, and then on into the realm of antidepressant drugs from there. So anybody have any questions? Thanks a lot, everybody. Be safe and stay warm. And there's more storminess coming, it sounds like, in terms of weather. So be on the alert for that if you're out there on the roads at all. And we'll see you next Tuesday. Tuesday and Wednesday are our final days of class. Next week we'll be busy, but hopefully we'll have a lot of fun too. See you then.
Hi, Keith.
Hello, Katie.
How's it going?
Well, fine by me. I hope hopefully students survive the lecture. I'm a little bit scattered, but I do better sometimes than others.
Well, I think that, we've been discussing opioids for a while now, so I think it's nice for them to hear it from a couple different perspectives, when we revisit the topic.
I do too, because it's such a vital area that a little bit of repetition or repetition associated with some additional things, I think is a good deal too. So anyway, I thought the